Hey guys, we're looking here at the distance rule or the distance formula. Context is a little different and a little more elaborate, so it's a really good one for understanding how to use that distance formula. Prove that the following triangle is isosceles but not equilateral. And then we have these reminders. An isosceles triangle has two side lengths that are the same, whereas an equilateral triangle has three identical side lengths. So in other words, we need to know what are the side lengths of each of these sides of the triangle. In other words, how long is this line segment right here? How long is this line segment right here? And how long is this line segment right here? And if we have two of them the same, then it's an isosceles triangle. If we have all three the same, it would be an equilateral triangle. I'm going to start off by naming those points on this triangle. I'm going to call them A, B, and C. And what that's going to do is just help me show my work a little bit more clearly. And I'm going to go ahead and find which one is going to actually turn out to be the easiest one. It's a straight line across here. You can see that the y's don't change. I'm going to find the length of segment AB. In other words, I'm going to find the distance from A to B. And I'll do that down here. So the distance from A to B. And that's going to be equal to the square root of. Now, in distance formula, we have the same thing applied all the time. It's going to be x2 minus x1 squared plus, open brackets, y2 minus y1 squared. And all underneath the square root, with that big square root being last. You've written down those steps. You can refer to them right now. And so now I just need to decide which are going to be my x1, y1, and which is my x2, y2. So for this particular example, I'll just take a quick second. I'll label the points over here. I don't want to muck up the triangle just yet, because when I'm doing this distance and then I'm going to do this distance, and I don't want to confuse all my x1s and x2s, I'll just write out my points. So point A is negative 12, comma 4, and point B is 6, 4. And so I'll call that x1, y1, and I'll call that x2, y2. It's a good idea to always write out your points before you do a calculation. It just makes everything nice and clean. And then, excuse me, we'll remember that we're calculating this length right here. So to get that, we're going to take the square root at the end of, and now we're going to plug in our numbers. So open my brackets. x2 is 6 minus negative 12 squared plus, open brackets, y2, 4 minus 4. Squared. So that is going to be 6 minus negative 12 is going to be 18, positive 18 squared, plus 0 squared. Now 0 squared is 0, so at the end of the day, we're going to take the square root of 18 squared. Now, I don't know if you realize this or not, but look, we're going to take the 18 and we're going to square it, and that's going to equal 324. And then we're going to add it to 0, which is going to remain at 324. And then the last step is to take that square root, and that's going to come to 18 again. So that is 18, the length of segment AB, or the distance from A to B, plugged into the distance formula. Now I'm going to do the distance from B to C. I could do A to C next, but I'll do B to C. So again, just give you a sense of what I'm doing. There's different ways that I can label this. Let's write it just a little differently, show you a different style. The length of, or the distance of, B to C. So I'm going to go BC right there. It's a line segment sign, and I can do that there too. And I want that distance, and that means I'm going to need 2 points for B and C. So I got to call one of them point 1 and one of them point 2. So I'll write down B right here. B is 6, 4, and C is negative 3, negative 8. And I'll call this x1, y1, and I'll call this x2, y2. And the formula for the distance we already know, but I'll write it down again. Square root x2 minus x1 all squared plus y2 minus y1 all squared. And now I'll do my substitution, put in my numbers. So x2, negative 3 minus 6. So open up my brackets, negative 3 minus 6 squared plus, open my brackets, y2, negative 8 minus 4. So don't get messed up with the negatives here. You saw this in the instructional video, or the introductory video just previously. Negative 3 minus 6, right? Negative 3 minus 6 more is negative 9. And I want you to keep those brackets there as a way of not making a mistake. Same thing with negative 8 minus 4. Negative 8 minus 4 is going to come to negative 12. Keep those brackets around that negative. When we square here, we want to make sure we're squaring the negative. If you get negative answers here, then you've made a mistake, right? If you go negative 9 and you square it and you hit equals and you get negative 81, you know you've made a mistake, because this cannot be negative once you've squared it. A negative times a negative has to be a positive. And so the easiest way to make sure is to go, hey, open up that bracket, negative 9, close the bracket, then square it, and there's your positive 81. And when you do the same thing over here for the 12, you're going to get positive 144. Negative 12 times negative 12 would be positive 144, negative 12 squared. So that is going to come to, so we'll add that 144 now, and we get 225. And we have to take the square root of that 225. So clear, square root, 225, 15. So BC is 15. So we know right away that we're not dealing with an equilateral triangle, because these would both have to be 18s or both have to be 15s. So since we know it's one of the two, chances are it's going to be isosceles. But we'll prove it by making sure, by calculating the distance now from A to C. So the distance from A to C will be equal to the square root of, right? Same thing, x2 minus x1 squared plus y2 minus y1, also all squared. And again, it's a handy thing to label your points. So I'll call A negative 12, 4, and I'll call that my x1, y1. And then for my C, negative 3, negative 8, and I'll call that my x2 and my y2. Again, it's just a way of staying organized. So that's going to equal the square root of x2, negative 3, minus negative 12. So be careful there. A lot of negatives. Plus y2, negative 8, minus 4, minus y1. So that's going to be equal to the square root of, now negative 3 minus negative 12, I mean, a lot of you will kind of do that in your head, but just in case, negative 3 minus negative 12 is positive 9, which we have to remember is squared, plus negative 8 minus 4 is negative 12, which is squared. Remembering again that we have to square that negative. And that's going to give me a positive 81 plus a positive 144, right? Negative 12 times negative 12. If you're getting negative here on your calculator, use those brackets. And that's going to be equal to 225. And then that last step is to take the square root of that number, which is 15. So since we're getting 15, a 15, and an 18, we know we are dealing with an isosceles triangle. This is a really good example of how we can use the distance formula in an application to show something else. But at the end of the day, we still need to realize that when we're getting the lengths of line segments or the distance between points, that this is the formula we need to use.